Welcome to Python Pro, a 30-day workshop by CTC. And today we'll be looking at the error handling part. So if you're thinking what error handling is, say, as the name suggests, say you're being prepared for something unexpected in your code, like figuring out what went wrong and making sure that things are in order. So your code goes as per flow. That is what error handling means. So error handling uh, to the typical definition goes like refers to a practice of managing and responding to exception or errors that may occur during your execution. So an exception is nothing but an event that disrupts the normal flow of a program's instruction, and it can be of any cost. The cost might be of, say, invalid input, or file is not found, or division by zero. These are some common examples of why an error may occur. And say to handle all these errors, we have four main keywords that we use, which are try, except, else, and finally. So try holds a block of code that might raise an exception. That means this code is say this code is prone to any error. Say whatever error might occur, you put that code inside this try block. And this except block is where you're going to handle those errors that might occur on the try. Say, if the user is going to enter some string input rather than an integer, you can have the except block saying that user has entered the wrong data type, say as the input. So you can have the except block carrying that. So except can be more than one. You can have more than one except for a try block, and it is similar to, say, the switch cases that we saw. The try block will search if there is any exception for the particular case, and if there is an exception, it is going to execute that. So some common exceptions that we might encounter are moving on to the first one, the syntax error. Syntax error is when you don't follow the proper syntax. Say here parenthesis is missing. So this is going to raise the syntax error. And next we have an indentation error when you don't follow the indentation. Say in Python you have to give a tab and then write the code block if you're using if for any function or any class. So you get that error raised. And name error is when you use an undefined variable name. Say you give small a as variable and you use capital A, it is going to say it is an undefined variable. And then type error is when you use inappropriate data types. Say here I'm concatenating string and an integer, which is not happening. So we get a type error. And a value error is raised when, say, you use not the proper input for a function. Say over here I'm trying to convert a string into an integer, which is not possible. So it is going to throw a value error. And then the zero division error is when we divide any number by zero, it is going to give us, say, infinity by math, but over here it is going to throw an error called zero division error, which means it is not possible to divide by zero. Say, be it a modulo function or a division function, it is going to throw a zero division error. And next on line, we have the index error. So this occurs when you're giving the indexes out of your range. My range over here is just 3. Say it starts from 0, 1, and 2. So whatever I want to access, say, I can only give these 3 index. I cannot give anything beyond this. I cannot give 3 or 4 or 5. This is going to raise an index error because my range is confined from 0 to 2. And moving on to the key error is when, say, my dictionary, here I've declared only one key and one value. And I'm going to say fetch, I'm asking to fetch a key of 2, which is not even listed in my dictionary. So key not found that is when you get a key error. And lastly, we have the file not found error. It occurs when you're trying to read or write a file that has not been created or that doesn't exist. And moving on, with the say the we saw try block, except block, and we have something called else and finally. So this else block is nothing but, say, if no exception occurs, say if nothing goes wrong, you can use this else block where you know, where things go smoothly, when your code has no error, say there is no exceptions that you may encounter, those part of code can be given in the else block. And the finally block is used to execute whether, no matter if an exception occurs or not, this finally block, as the name suggests, is going to execute at the end. Say whenever it encounters a finally block, it is going to execute no matter if an exception is raised or not. So this is used to, say, closing a file or network connections. That is the major purpose of finally block. Let us see some examples on how try exception error handling works. So here I have all of the examples. I have a try, I have an accept, multiple accept, and then an else part and a finally part. Let us see how this is going to go. So in my try part, I'm giving result equal to 10 divided by 0. This is supposed to raise a zero division error. So I'm putting my code that is going to throw an exception inside the try block. And when this exception, is encountered, say an error occurs in a try block, the exception catches the error and then it handles the error. Uh, Say how we manage it. Say here I'm just printing the error, whereas you can suggest some methods, say not to do this, or the input form is invalid. Like that, you can just ensure that the user gets conveyed that an error occurs due to this. So over here, result 10 by 0, it is going to give me the zero division error. The zero division as is nothing but the the zero division error, which is a type of error that occurs. We are going to say the variable is going to store an instance of this exception. So it's just going to store that zero division error. This E, uh, we are mentioning zero division error as E in a variable. That's it. And moving on, we have another exception. Say if not this error occurs, if any other exception is uh, going to be there, we say an unexpected error, and the exception, similar to the zero division error, we are mentioning it as E, and the variable is also given inside. And the else part, where if none of the exception rises, say this part will be executed. And finally part, no matter what exception occurs or not, this is going to be executed always. So let us see how this code runs. So the error occurred in the try block, so it moved to the except zero division part, and we have our print statement getting executed. And since we had an, say, the try block got executed, the else part is not getting executed, and then finally part is executed no matter what. Say let us try something else. So now the else part is executed because no exception was raised, and the finally part is also executed, say, because no matter what, your finally block is going to be executed. Say some other error over here. Let us see how this is going to run. So as you can see, there is something called the unexpected error. The second except case is being executed here, and then the exception that occurred is stored as E, and the E is also printed here. So the exception that occurred was this variable was not defined, and no matter what, as always, our finally part also got executed. Here's yet another example where we are going to check, we are going to get the age from user, and if the user is going to enter a negative value for the age, we are going to raise an error stating that, raise an exception stating that age cannot be negative. So this raise keyword is used to handle a specific condition. Say your condition is that age should not be less than 0. So that is your condition. And for this specific condition, if you want to raise an exception, you will be using this raise keyword. And we are giving that age cannot be negative. And this except value error as E is to encounter if there is any other error other than age less than 0 constraint. Say some some character as an input, like that. So let us see how this code works. So I'm going to enter my age as minus 20. So this if part got executed, and let us see how this part gets evoked. So this value error as E is executed because I entered a character instead of, say, an integer value that is supposed to be there. Looking back, so we went through what was Python. Say Python was a high level language, it was more to the human readable format, and we went through what are libraries and what are frameworks and what actually are variables, and then we went to how to write these variables. We had the syntax. You had you're not supposed to start with digit, you can start with an underscore or a, say, alphabet, and then you're not supposed to use keywords and all those syntax rules. And then we saw comment lines, the hash and the triple double quote, the single quote. And then we had the indentations and variable types. And then we moved on to the operators like the arithmetic, the logical, and more operators. And then we saw what and all can we do with lists, what are mutable data types, what are immutable data types. List is mutable, tuple is immutable, set is mutable, but frozen set is immutable. And in dictionary, the keys are immutable and the values are mutable. So if you're thinking again, what is mutable and immutable? Mutable is when you can change the data, whereas immutable you cannot modify once you declare or initialize it. And moving on, we had some common built-in functions that we used along with the list and tuples and set dictionaries, like the count, the delete, the pop, and say append, and more built-in functions that we saw. And we came across the escape sequence, which was nothing but say the slash n, the slash t, a set of say a set of letters with a slash in the front. So those specify a unique purpose. So if you want to have a new line, you put a slash n there, and if you want tab, say 4 spaces, you put a slash t. That is how we went through the escape sequence. And the conditional statements, where you have the if, elif, and else, and then we moved on to the looping statements, where we saw the for loop, the while loop, how we nested them, and how to convert a for loop to while loop and a while loop to for loop. And lastly, we saw the error handling methods where we went through the try, the try, the accept, and else, and finally part. And this is a small short summary. Say the first one we were doing was error handling. So the four things. I'm going to repeat it again. So it is going to be the say try, accept, else, finally. These four things are main in error handling. And secondly, we saw the match case, which is similar to the switch case in other programming languages, which is very much an if else or if elif. And then we had something called the dictionary mapping. And then we went through the control flow statements, which were the continue, break, pass. Continue skips to the next iteration, where break breaks the loop, and pass does nothing. It just, no matter what your condition statement does, it is going to just let the code pass. And then we had something called as circular indexing. In circular indexing, we just made sure that the index doesn't go out of range, say when you're allocating in a circular way. Say you want to get back to the finish, or you want to get back to the end in a loop while you iterate through the index, you use the circular indexing. So that is attained by you either put I plus 1 mod n or I mod n. I plus 1 mod n is more appropriate because once you iterate, say you have only 5 elements in your list and it goes to 6, and you get the in say the mod returns the reminder. You either get 6 mod 6 is 0, and then you come back to the 0th index, and that is how circular indexing works. And we had an interesting game where we used random library, and from that library we used a function called randint to generate random integers. And so on, moving on, we have a lot of functions like random. Say you have random, and you have more such random number generating functions. Randint is particularly for integer, where random is going to give you some float values, and the dictionary dot get function, this is used to retrieve a specific value from the mentioned key, and the default is going to go when your key is not found. And we use something called f-string almost in all of our examples. F-string is nothing but, say, this expression's value will be replaced inside. So whatever expression you give inside the braces, using f-string is going to return you the exact value uh, that is outside the print function. See, so the upcoming weeks we will be looking at the OPS concept and the DSA. So meet you there.